Hey everyone, here's our next video, our last one for this chapter, factoring polynomials completely. So our essential question is just how can you factor a polynomial completely? Factored completely is just a polynomial that is written as a product of unfactorable binomials. And then factoring by grouping, you guys have been doing factoring by grouping with the AC split a lot, so this actually should be pretty easy and pretty natural for you. Make sure you get these definitions written down and the essential question, because remember, you guys are going to be graded on your notes. Again, with this core concept, they're just defining what factoring by grouping is. So if you want to pause the video and read through it really quick, you can. But I'm going to jump right into our first couple of examples. So really, you guys, when you look at letter A right off the bat, hopefully your eyes are kind of trained to say, okay, group the first two together, group the second two together. I can take out an x squared, which brings me to x plus 3. I can take out a 2, which brings me again to x plus 3. So my first factor is x squared plus 2. My second factor is x plus 3. And that's all you got there. Just mentally take a quick note, you guys. With this first term right here, this x plus 2, this x squared plus 2, there might be times, like if that was x squared minus, let's say, and then let's say that there was a 4 back there, you would be able to factor that further. So just be aware they might throw a type of problem like that at you in the future. But taking a look at letter B, when I look at these first two terms, there's nothing in common there. When I look at these second two terms, yes, there is an x in common, but really this front right here is the problem. So let's go ahead, let's just rewrite so that I have common terms with each other. Let's see, I want to do x, y first. Okay, so now if I group these first two and I group these second two together, now if I take out an x, I'm left with x plus 1. And then if I take out a y, then I'm left with x plus 1. And that shouldn't be squared. Why did I write down that that was squared? It should just be x. And then I've got x plus 1 as one factor, and then x plus y as the other factor. So I encourage you on the next slide to go ahead, try these next two problems on your own, pause the video, and give it a go. First problem is exactly like example A. Second problem is exactly like example B. So go ahead, give it a try. Okay. So now, when I look at these two, again, I just grouped the first two together in example 1, the second two together in example 2. Again, just kind of taking a look at this solution here. If that was a squared minus 1, that would be factored further. So just a heads up. In example 2, I went ahead and I rearranged. So I put y squared and 2y together, and then I put these middle two terms together. If you rearranged it so that you had the 2's together and then the y squared and the yx together, again, you're going to come up with the exact same answer. Whoops. Okay. So now, with example A, down on the bottom of your note packet, what I want you to take a look at is, first off, is there anything that I can factor out? Hopefully you guys are kind of getting to the point now where you're able to recognize that I am able to pull out a 3x, which leaves me with x squared plus 2x and then minus 6. If I start thinking about here, because normally we're able to take that and we're able to factor it down further, but if I even start trying, if I have, if I just put my x and x there, I have to think of ways to get negative 6. Like if I do negative 2 and positive 3, okay, that'll give me negative 6, but I have negative 2x, and then I have plus 3x. That's not going to give me positive 2. Okay, so you just have to be aware that now we're getting to the point where it might be unfactorable, which it is in this case. So we're just gonna leave our solution as is. Taking a look at example B now, I'm gonna take out a 7x squared, which means that I have x squared minus 4 here. This I can factor further. So I've got 7x squared. I'm going to factor that down. Hopefully you guys are able to recognize that I have to have opposing signs. I have to have positive and negative. And then I've got 2 and 2. Again, go ahead, pause the video, try these next 3 on your own, and let's see what we can come up with. All right, so you've got 3x times x plus 2 times x minus 2. Again, you can take that x squared minus 4 and break it down even further. So that's one of those polynomials that we have to be able to start recognizing. Number 4, you get 2y times y minus 3 times y minus 3. So actually what we can do there, you guys, and what we should do, and I just forgot to, that should be y minus 3 squared. So I'm pretty sure that this is the answer that your book is going to want. And then you've got m times m minus 4 times m plus 2 for your answer for number 5. Okay. Again, this is a type of problem that you guys have seen a bunch the last couple of days. Hopefully your instincts are starting to kick in and you're like, okay, well, first thing I'm going to want to do here is I want to make sure that I'm getting that equal to 0, and then I've got everything on the same side. So this is going to turn into 2x cubed plus 8x squared minus 10x, and I'm going to set that equal to 0. Now we're able to see, okay, well, I'm able to take out a 2x, and when I do that, I've got x squared plus 8x minus, whoops, that's not 8x, is it? That should be 4x. And then minus 5. And then I've got 2x. This I can break down further. I'm going to start out with x and x. Then I've got 5, and I've got negative 1. And then I'm going to go ahead and I'm going to follow the zero product property. So I'm going to take 2x, I'm going to set that equal to 0. I'm going to take x plus 5, I'm going to set that equal to 0. I'm going to take x minus 1, set that equal to 0. Let's solve each of these for 0. So here I'll divide by 2. Here I'm going to subtract 5. Here I'm going to add 1. So I'm going to have x equals 0 for one solution. I'm going to have x equals negative 5 for a second solution. And then I'm going to have x equals 1 for my third solution. So again, take a few minutes. Try the next examples on the next slide, or on the next, whatever. You've got 6, 7, and 8. Try 6, 7, and 8. Do those. Pause the video and see what you can do. All right, so here is the last one, the last few examples. W equals 0, W equals 4. Again, although W minus 4 shows up twice, you only have to solve it once. Because even, I mean, if you have W minus 4 equals 0, W minus 4 equals 0, you're going to come up with the exact same answer. For number 7, x equals 0, x equals negative 5, x equals 5. And then for number 8, you have c equals 0, c equals 3, and c equals 4. All right. I think the word problem is going to be a different video, so we're going to be done with this one for now. I might even just do this one in class with you guys so that we can look at this one together. And actually, I think that's what I'm going to do. So I'm done with the videos for right now. And yeah, okay, I'm done. We'll see you soon.